Hello, everyone. My name is Nazli Purba, and I'm delighted to welcome you to my presentation. Today, I'll be discussing the research and finding from my SOC 590 class assignment. This work not only fulfills an important requirement for the course, but also lays the groundwork for my upcoming master's thesis project. Thank you for joining me, and let's get started. I'll be talking about the concept of AI enhanced virtual reality as third spaces and why this idea is so important in modern education. First, what do I mean by third space? Traditionally, our social lives are divided between home, the first space, and school or work, which is the second space. A third space is an environment outside these two, where people can interact more freely and authentically. In education, third spaces have become crucial. Classrooms can feel hierarchical. Some students may not feel comfortable speaking up or expressing their ideas because of peer pressure or other social dynamics. And if you don't address this, many voices go unheard, engagement drops, and learning is less effective. So, what makes virtual reality an exciting third space? Unlike physical third spaces like cafe, parks, or community center, VR spaces are not limited by geography. It can remove real world barriers related to physical mobility, appearance, or location. In many ways, VR as a third space can be more inclusive and accessible than physical spaces. To put it this way, instead of you going to the third space, we bring the third space to you. So how does AI enhance virtual reality? The first is through an AI agent that behaves like a non-player character or NPC. Unlike traditional video game characters with scripted responses, AI powered VR avatars can understand natural language, adapt to students' behavior, and engage in meaningful conversation. This makes interaction feel richer and more realistic. This AI powered avatar can personalize the VR experience to individual needs. For example, it can serve as a counselor or therapist, providing a space for students to share their daily challenges and receive feedback, whilst helping them feel heard and acknowledged. It can serve as an academic advisor, closely monitoring students' progress from daily needs, such as helping to prepare study sessions, to more complex things such as designing a roadmap for research. So, what is embodied dialogue? Simply put, it's a way of communicating where participants are represented not just by words or voices, but by avatars or digital bodies. In virtual spaces, we don't just hear each other, we see gestures, expressions, and body language, just as we do in face to face conversation. This creates a richer, more authentic interaction. And why does this matter? Because so much of human communication is nonverbal. Embodied dialogue enables us to feel more connected, to read emotion, and to build trust, even when we were miles apart. This has powerful application in education, therapy, team collaboration, and remote social gatherings. In summary, exploring third spaces through AI and VR offers great potential as technology continues to evolve and create new digital experiences. Embracing these innovations is essential. Otherwise, students risk falling behind and their contribution may be overlooked. Our first research question is: how can AI driven VR support third space engagement? This means how can AI in VR help build informal communal spaces similar to the third places we know in real life. Most current research is on VR for meetings or games, but the role of AI in creating this informal environment is still unclear. Our second question is, how does embodied AI dialogue affect belonging? This is about the impact of interacting with human like AI avatars on users' feeling of inclusion. And our third question is, which design features matter? Here, we want to find out which specific aspect of VR, like realism, customization, or interactivity, are most important for fostering third space engagement and belonging. To ground my research, I first looked at three key areas: third space theory, virtual reality embodiment, and AI driven dialogue. Third space theory examines how identity and voice develop when people interact in hybrid or blended spaces, which is highly relevant for immersive digital experiences. Next, studies in VR show that embodiment, the feeling of presence in an environment, can strongly impact emotional responses and engagement. Meanwhile, recent advances in AI enable adaptive, responsive dialogues that mirror real interpersonal communication. However, here's the gap. To date, there is no substantial research has truly integrated these areas. No studies explore how VR embodiment and AI driven adaptive dialogue together influence identity or emotional presence. My research aims to fill this gap by combining these elements, leveraging the potential of both VR and AI to create more immersive, interactive environments that better support personal expression and social connection. Now, let's talk about theoretical framing. First one is third space theory. We are guided by third space theory, which suggests that new hybrid spaces where formal and informal or cultural and institutional boundaries merge foster creative learning and identity development. In our VR scenario, we intentionally create a third space where users can blend aspects of their personal experiences with formal learning, encouraging innovation and deeper engagement. Second theory is embodied cognition. Embodied cognition emphasizes that thinking and learning are deeply connected to bodily action and sensory experiences. Because VR make use of movement and spatial awareness, it's an ideal platform to put this theory into practice. Users engage with content physically, manipulating objects or navigating spaces, which we believe strengthens understanding and memories. And third theory is human AI interaction. Human AI interaction theory explores how we collaborate with artificial intelligence, considering our aspects like trust, agency, and co adaptation. Our VR project incorporates intelligent agents to assist and learn from users, creating creating dynamic learning relationships that adapt to individual needs. This aligns with our goal to personalize and enrich the user experience by harnessing AI. Our first hypothesis is that the combination of VR and AI will increase the feeling of belonging for participants. This is grounded in prior research, which has shown that immersive environments can foster social presence and inclusion. As cited by Smith and Jones in 2022, when users interact in shared VR spaces, they report stronger connection and an enhanced sense of community compared to traditional online platforms. By integrating AI driven interactions, we further personalize this experience, creating an environment where individuals feel recognized and accepted. Thus, drawing on both social presence theory and the literature on digital belonging, we anticipate that VR with AI will increase users' sense of belonging. Our second hypothesis is that embodied dialogue, where participants use avatars with expressive gestures and voice, will enhance engagement. Research by Lee et al. In 2019 demonstrates that embodiment in virtual settings lead to deeper cognitive and emotional involvement. The ability to communicate through virtual bodies makes the dialogue feel more authentic and dynamic, as described by embodiment theory. Previous work suggests that when users perceive their avatars as extensions of themselves, their willingness to participate and stay engaged rises significantly. Therefore, we propose that embodied dialogue will elevate engagement levels in our third space VR context. And finally, our third hypothesis poses that VR embodiment will deepen users' self reflection. According to Didi in 2021, immersive VR experiences promote self awareness and critical thinking by allowing individuals to view themselves from new perspectives. Theoretical framing from transformative learning theory suggests that embodied experience challenge existing beliefs and encourage introspection. Prior studies have found that when users inhabit virtual bodies, they often report enhanced awareness of their own attitudes and behaviors. This supports our expectation that VR embodiment facilitates deeper reflections. Now let's talk about research design. This study uses a mixed methods approach because combining quantitative and qualitative data provides a fuller understanding of VR and AI interactions. Integrating both methods allows us to validate results and capture both general patterns and individual experiences, making mixed methods ideal for this research. Step 1: Pre-survey. This is to collect baseline data and understand participants' initial perspectives. This allows us to quantitatively measure participants' initial attitudes, experiences, or knowledge levels. Step 2: VR session with AI. Participants engage in a virtual reality session involving AI. This interactive, immersive stage lets us observe behavior and collect data. Combining qualitative observation with system logs provides depth in our analysis. And step 3, it's post-survey and interviews. This is to capture reactions, changes, and deeper reflections. After the VR session, we create a post-survey and conduct interviews. The post-survey gathers quantitative data on changes in attitudes or knowledge, while the interviews provide qualitative insights, motivation, and other unexpected outcomes. For this exploratory project, our sample will consist of 20 to 30 students from Portland State University. Our recruitment strategy will be three ways. First, we will utilize snowball sampling, where initial participants refer peers from their network. Second, we will work with relevant departments to help distribute our study invitation more broadly among the student population. Third, we will set up a testing booth with a VR headset around campus. It's important to highlight that because our project is exploratory, our sample is not intended to be statistically representative of all PSC students or the general population. Instead, the goal is to gain in-depth insights and identify patterns or themes that can inform future research. This approach will allow us to be flexible and adaptive, which is essential when investigating a new or emerging phenomenon. In our case, the experience of third spaces in virtual reality among students. Ultimately, the use of a non representative small sample fits the project scope. Our aim isn't wide generalizability, but rather to open up questions for further investigation and suggest possible direction that could be explored in larger, more systematic future studies. Now I'll walk you through the analysis plan for our project. Quantitative analysis. First, we will use quantitative methods to compare data collected before and after our intervention. This approach will help us measure the actual impact numerically, allowing us to track change over time and draw objective conclusions from the data. Next is qualitative analysis. Alongside the numbers, we believe it's essential to capture participants' perspectives. We will do this by conducting interviews and an in VR ethnography, then analyzing these using thematic analysis. This will help us uncover patterns and themes in the experiences shared by participants, providing depth and context that numbers alone can't deliver. Lastly is timeline. Our work will follow clear timeline. Prototype, recruit, collect, and analyze. The timeline starts with developing a prototype. We will then recruit participants, proceed to data collection, and finally analyze the result. Sticking to this plan ensures that we stay organized and progress efficiently through each phase. For this project, we have designed a minimal risk institutional review board or IRB application. This means our study poses no greater risk to participants than they will encounter in everyday life. This careful approach ensured maximum safety for all participants involved. Handling emotional disclosures. In situations where participants might share emotional or sensitive personal experiences, we have established clear protocols. Any disclosure will be met with support, and participants will be provided with resources such as counseling or helpline contact if they need them. Next is data storage policies. Importantly, we are committed to maintaining participants' privacy. No biometric data like heart rates or facial scans will be stored at any point in the project. This eliminates one key source of potential privacy concern. Anonymize AI logs. Our system does use AI to analyze interactions, but all logs are fully anonymized. This means that any identifying information is removed before storage or analysis, so individual participants cannot be traced from the data. One significant limitation is the small sample size of participants in our study. This may restrict the extent to which our findings can be generalized to a wider population. To address this, I've taken great care to ensure that the participants we did recruit represent a range of backgrounds. In future research, with more resources or time, I will aim to expand our participant pool for greater reliability. Novelty effects. Another challenge is the novelty effect. Participants may respond enthusiastically simply because the technology is new to them, not because of its inherent effectiveness. To mitigate this, I incorporated follow up sessions and gathered feedback over multiple uses, helping to differentiate between initial excitement and genuine impact. Next is researcher design bias. As the researcher, my own perspective and assumptions can influence the design and interpretation of the study, known as design bias. But being reflexive, I consistently reflected on my own role, kept a research journal, and sought feedback from peers. These help me remain aware of potential biases and strive for greater objectivity. Next is limited time and resources. Mixed method studies often require more time, personal, and funding due to the need of collect, analyze, and integrate two types of data. Extending third space theory into virtual reality with the support of artificial intelligence can address and enhance experiences of belonging and reflective safety. Our approach frames VR AI as a promising environment for fostering community and inclusion. Its key elements in third space literature. By designing VR spaces that allow for multiple identities and shared meaning making, we support both social and psychological safety for participants. The approach answers research questions. This approach directly addresses our research questions about belonging and safety. By situating our work within established theoretical conversation, we add new evidence. VR AI can be more than just a tool. It can be a transformative space for connection and personal reflection. Next thing is open questions. First question is, how do we meaningfully measure safety in VR spaces? Psychological and reflective safety are complex to quantify, and more work is needed to establish robust, participant centered metrics. Second question is, how directive should AI be when guiding users? There's a balance between autonomy and general intervention, and future research should examine where that line best serves participants. And final question is, what other risk should we consider? For example, unintended consequences related to privacy, bias, or exclusion in AI-driven environments. Next up is contributions. To conclude, this project contributes both theoretical extensions, which is bringing third space concept into new digital contexts, and practical design strategies for VR AI environments that support belonging and safety. Thank you.